Transition technology ready now. Transforming the North Sea to net zero operations requires forward-thinking and innovative engineering. We have invested in pioneering technologies that are well on their way to disrupting the current energy system. Let's take a closer look at some of the technologies that are ready now for deployment and adoption. Transition technology ready now. Technology 1. Interblock Interview. Lifting and the use of cranes is fundamental during construction, operation and decommissioning of infrastructure across the energy sector. Lack of visibility during crane lifting operations can cause accidents and impact project schedules. Combining digital technology with the development of new skills will create a safer and more efficient working environment. Interblock Limited has developed Interview, a wireless camera, both ATEX and non-ATEX rated, which is mounted on the crane block and connects to a display unit located in the crane operator's cab. Images are displayed in real time on a high-definition screen, with the technology incorporating a people tracking function. This alerts the crane operator to potential hazards and ensures they have full line of sight during operations, avoiding blind lifts and collisions with objects and people. This innovative camera system is battery-powered and easily retrofitted to any crane. Unlike wired systems, Interview does not require specialist vendors to travel to site. This also avoids the need to shut down the crane for fitting. It can be fitted using magnets and lanyards in minutes rather than hours. This technology is proven to reduce the time taken per lift, the reliance on radio communication, and the number of banksmen required, culminating in estimated total annual savings of £3.2 million across the UKCS. As we create the energy basin of the future, Interview will ensure safer installation of wind turbines and other infrastructure, lowering the number and severity of lifting incidents. Technology 2. TowRob, autonomous robot for visual inspection offshore. The offshore energy industry faces a complex challenge to monitor and maintain assets and equipment in harsh industrial environments and hazardous settings. Traditionally, inspections have been performed by deploying teams of personnel. However, as these types of examinations entail high-risk situations and long periods of time in the field for the crews, operators are seeking safer methods for inspection, repair and maintenance of their topside and marine offshore infrastructure. The Offshore Ground Robots Industrial Pilot, OGRIP, funded by Total and the Net Zero Technology Centre, is the foundation of the TowRob Inspector robot, which is designed for offshore inspection and surveillance and to serve dutifully in harsh industrial environments, volatile atmospheres, and adverse weather conditions. It is capable of undertaking routine inspections semi-autonomously, or it can be controlled by a technician working remotely or locally. Thanks to its precision sensors, the TowRob Inspector gathers data with unprecedented versatility and objectivity. The robot uses advanced sensors to recognise where it is on a facility. It takes ultra-high-definition photos and videos, records sound, detects gas leaks through thermography, monitors concentrations of toxic and flammable gases, and oversees its environment with a 3D LiDAR scanner. The TowRob Inspector has completed a 12-month field test at Total's Shetland gas plant, which saw the successful deployment of 4 robots in an industrial environment. With a one-time deployment cost saving of £275,000 for inspection and maintenance activities, TowRob Inspector reduces inspection costs while increasing both efficiency and safety. This technology has the overall potential to deliver a saving of £127 million annually to the UKCS alone. Reducing the need for people to travel offshore will cut helicopter use, decreasing emissions and overall carbon footprint. Technology 3. FlyLogix, remote methane detection. The UK oil and gas industry is committed to halving operational emissions by 2030. Eliminating methane leakage will be crucial to achieving this target. However, there is currently limited capability to measure methane emissions from individual offshore assets, with reporting based on estimates, creating significant measurement uncertainty. FlyLogix, in partnership with Seacops, has developed a pioneering methane measurement and quantification technology. Integrated with an autonomous unmanned aerial system, the fixed-wing drone is mobilised from shore and can fly up to 600 kilometres beyond visual line of sight to an offshore facility. Measurements taken using a highly sensitive miniaturised laser spectrometer are captured from a distance of 250 metres from the asset, optimising accuracy whilst minimising disruption. In a single flight, the technology captures over 90,000 data points of methane concentration. Data is fed back via satellite to enable real-time viewing. Further post-flight analysis determines the methane emission rates from the facility, which can then be used to validate calculated estimates. Routine methane monitoring is enabling operators to accurately measure, monitor and report on emissions, demonstrating the gold standard for measurement and evidencing clear ESG value. No persons are required offshore, and the technology uses 98% less fuel than an offshore helicopter, making it greener, safer, and more cost-effective than other alternatives. Currently, the solution is already being deployed by operators responsible for 50% of all UKCS producing assets. An annual measurement campaign from FlyLogix could save £140,000 per asset and potentially £17.6 million annually across the UKCS, assuming a 25% uptake within the industry.